Our task for lesson 3 will be doubling numerators and denominators. We are going to be doing a task, 2 questions on our task regarding how does the value of a fraction change if you double its numerator, and we're going to explain the answer. And how does the value of a fraction change if you double its denominator? And we're going to also explain that answer. Okay? So I'm going to give Macy a fraction problem. And we're going to discuss how we double the numerator and what it changes. So Macy, do you know what a numerator means?
A numerator is the top number of a fraction.
It is the top number of a fraction. You're exactly right. But actually, what is a numerator? It tells you what?
It tells you how many pieces that are shaded or colored in or something.
Okay. And then the denominator. What does that tell you?
The denominator is the bottom number on a fraction and the whole number of the fraction.
Okay. How many equal sized pieces make a whole, correct?
Uh-huh.
Okay. So we know what a denominator and a numerator is of a fraction. I want you to write the fraction 5/8 on your paper. Okay? What we're going to be doing is we are going to be doubling the numerator. And tell me what the numerator is, the 5 or the 8?
The 5.
Okay. So when you double something, double the value of a fraction, what happens?
You pretty much just add them on top or just multiply by 2.
You are multiplying by 2 because you're doubling that 5. So we need to show that we are timesing the 5 by 2 and solve that math equation. And what will stay the same? We're just doing the numerator.
Oh, okay.
The denominator will actually stay the same. Okay? We'll do the denominator in a minute. So our first question was, how does the value of a fraction change if you double its numerator? It changes by twice as many what?
Twice as many pieces.
Twice as many pieces. So you told me earlier that a numerator tells you how many pieces there are. So if we're actually doubling the numerator, which will make 5/8 10/8, then we will have twice as many pieces as we originally did, correct?
Correct.
Okay, so since the denominator stays the same, the size of the pieces stay the same. Since you have twice as many of the same size pieces, the value of the fraction is doubled when you double the numerator. Okay? When you double the numerator of any fraction, you double the number of units fraction. So for an example, let's look at another one. If you have the fraction 4/3. Write down 4/3 for me.
Can I erase this?
Yes.
Let me erase.
And doubling the numerator would give you what?
Doubling the numerator would give me 3/8. I mean 8/3.
Which is 8/3, right?
Yes.
So the value of the fraction is what? When you double the numerator.
8.
Right? But the value of that fraction is what?
Number.
The value of your fraction from the original fraction we had would be
Double. Oh, double. Okay.
good, doubled. So you actually had 4/3. Then when we doubled it, you had 8/3, which actually makes that value go up. Correct?
Mhm.
Okay. So basically the value of the fraction is doubled when we do doubling the numerator. Okay, so let's talk about the denominator. And you told me at the front of the lesson that the denominator actually is how many equal sized pieces that make a whole. Okay, so we're going to look at this problem. We're going to look at 5/3. Okay, write down 5/3 for me. Okay, I want you to draw me a tape diagram of 5/3 of just the numerator. I'm sorry, just the just the denominator in a tape diagram. Good job. So that equals
3.
Good. That would equal 3. Okay. So if we doubled that denominator, what would happen to your tape diagram?
Well, there would be more.
Exactly, but you can't. You've got your 3, but this is actually a whole right now, right?
Oh, yeah. So there's a 1.
Excuse me. So this is actually one whole right now, correct? So your one whole will stay one whole. If you double your denominator, your whole structure will stay the same. But your pieces inside your whole is what will be doubled, correct? So, if we doubled this denominator, what would happen to that denominator? How would you figure the double out? You would do times what?
2. Because double means 2.
Exactly. So I want you to solve that fraction to where it's doubled. So your numerator would be what?
My numerator would be 5.
Exactly. And your denominator would be?
6.
Okay. So you've got 3 pieces from your previous fraction. So how would you double that to keep your whole structure?
You could cut it in half again.
Good. So you would physically add 3 more pieces into your tape diagram to where you're actually dividing that tape or those 3 pieces in half. So each of those would be cut in another half. Okay, you had 3 blocks and you split each of those blocks straight in half to actually make you have 6 individual pieces, which makes your
one whole.
One whole. You're exactly right. Good job. Okay. So that's the example of the denominator task and question. How does the value of a fraction change if you double its denominator? Okay. The number of pieces stay the same, but each piece is half as big. Okay. So the value of your fraction is half what it was when you doubled the denominator. Okay. If you double the denominator in a unit fraction, that means what?
That means that you're timesing it by 2.
Your unit fraction is
half. How big?
Half as big.
Half as big. Okay.
Good. So let's give another example. So 1/3. Write 1/3 down. We're going to double 1/3 in the denominator. Okay? So when you double 1/3, what do you get?
When you double 1/3, so would you times both the numerator and denominator?
Just the denominator.
Okay. It would be 1/6.
Okay, and if it takes 6 equal sized pieces to make a whole, then you must be what?
Half.
Half as
many?
Half as big.
Half as big.
As if it only took 3 equal sized pieces. So I want you to draw your tape diagram with your original 3 pieces. Okay, then you're going to make that double.
Okay.
To represent your 6. Good job. So you basically would actually double or split those in 6 pieces instead of 3 to make a whole. If you double the denominator of any fraction, the number of the unit fraction stays the same, but each unit fraction is half as big. So the value of the fraction is half what it was when you double the denominator. Okay? So when we look at our 2 questions regarding our doubling of our numerators and denominators, do you understand how and why that you how you explained your answer on both of those? So you completed both of those tasks. So the purpose of this task was to assess whether Macy could understand the meaning of the numerator and the denominator in a fraction. Okay?